All right, guys, we are so back. This is SpeKTrakR. It is a control voltage modulation signal generator, something most commonly associated with modular synthesizers. It comes as a Reaktor block, obviously, and as an Ensemble, can run standalone as a VST in any digital audio workstation, which is what I'll be demonstrating today. So, how does it work? It analyzes the input frequency response, produces something akin to a weighted average mean value centralized around the frequencies with the highest amplitude between the user-defined minimum and maximum frequencies. You keeping up with me? Now, it was originally a prototype component for a much larger signal processor that I have developed.
I'm a prototype for a much larger system.
You can think of it like a pitch tracker that produces a modulation signal corresponding to the lower the frequency, the lower the output value, the higher the frequency, the higher the output value. Now, before we get into the feature set, we have some big time credits and shoutouts. This algorithm was translated to Reaktor core by user Kalugo_. Tremendous thanks to Kalugo_. And Kalugo has a lot of amazing stuff in his portfolio. Here is his 3D drawing library inspired a lot of the UI elements I developed for this as well, the knobs and buttons stuff. Go check him out. Now, this algorithm is the Gortzel algorithm.
Gortzel. Guatse.
It was discovered in 1958 by our homie at IBM, Gerald Howard Gortzel. In this user library entry, Kalugo_ says, "I can't think of any possible use for this." Oh boy, it's been 8 years and you finally get your answer, buddy. Okay, so let's use the thing. Starting here, we have our input trim in decibels. When you see the backlight flashing, you know that you have an adequate input level. It's not a clip meter, it's letting you know that your input signal is okay. Then on the left, we have our threshold, signified by the greater than symbol, and our gate hysteresis, indicated by the less than symbol. So the input has to cross the threshold to open the gate, and it has to duck below the hysteresis level to close the gate. After that, we have the hold signal, which will hold the gate open after the input signal has ducked below the hysteresis level. In the bottom left is the mono input button, if you're dealing with a mono input signal, and it'll just use the left channel and save a little bit of CPU. Next is the spectrum window. You can left click and drag vertically along the y-axis to control the spectrum threshold, which is different from the input threshold. To be clear, this is the band spectrum threshold. Right click and drag along the horizontal x-axis to modify the low to high equalization balance tilt. At the bottom, you can left click and drag along the horizontal x-axis to control the minimum frequency selected. You can right click and drag along the vertical y-axis to control the range of frequencies you wish to select. Now in the upper right, we have our 4 actual Gortzel band parameters. At the top is the decay rate of the amplitude of each band. Below that is the masking rate, meaning it will smooth out the differences between bands. Next is the length of the refresh rate, or Gortzel bin size. And after that is the output smoothing rate, something like a low-pass filter, but it isn't that, it's a slew limiter. At the top center is the output value indicator and the selector for the idle value, which is the value that the output will return to when the input has fallen below the threshold and hysteresis. At the bottom right is the selector for the output polarity between bipolar and unipolar. And below that is the MIDI output channel and control change values for use as a standalone VST plugin. So SpeKTrakR has done everything that I have designed it to do. If you guys really like it and can find a use for it, I can expand upon it, because right now it runs at 32 bands. It's very CPU efficient. I could try to run it at 64 bands and see what we could get away with. Shout at me, yell at me, tell me if you think parameters could go higher or lower in the range. This is very experimental, so hit me up, guys.